So by the end of this video, you would have a very clear understanding of what are mutable and immutable types in any programming language. But in this video, we are considering Python. So in Python, everything is an object, right? Whenever you create any data variable, like any variable of any data type, whether it is an integer, float, or let's say some complex data types, right? Like lists, dictionaries, inside the memory, it is always created as an object. So now these data types are actually classified in two categories. So the one is the immutable data type and another is the mutable data types. So what's the distinction between them? So the distinction is basically it lies in whether an object's content can be changed after it is created. So for immutable types, so once the object is created, you can't actually modify it. So if you try to modify a value that is immutable, Python actually creates a new object in memory. It creates an entirely new object in memory and it doesn't touch the already created object. But for mutable types, let's say we have examples like lists or dictionaries. What happens is that the object can be changed in place. That means that the value that is present in the same memory location that can get updated or that can get changed, right? We will see deeply what are immutable types. So immutable types, for example, we have here integers, floats, booleans, strings. These are actually immutable types. So whenever you try to create a variable with these data types and you try to change it, Python always creates a new memory location for the updated value. So we will see this example better. We will understand this scenario better with an example. So let's say this is your RAM, right? This is your random access memory and all your programs that are running in your system are currently living in this random access memory. So let's say you have a Python process inside it, right? This is your Python process. This Python process, and let's say it is executing some code, and inside it, I will write it here. You have this statement that says a is equal to 100, right? So what happens actually, what happens internally, memory wise, is that the program creates a memory, it allocates some memory in your Python process, right? In your RAM, it allocates some memory for this particular variable and it gives the value 100 to it. So one thing we need to understand in Python is that variables, so this a is a variable here, right? So these variables are nothing but labels for your memory addresses. So this is a memory address which contains this value 100 and your a here is just a label for it, right? So this label is basically pointing to this memory address, I can say. So let's denote a label here. So this is your label A and currently this label is pointing to this particular memory address, whatever it is. So this is randomly randomly allocated address and it has this integer value 100, right? Let's say after some lines or after the next line itself, you assign a different value to A and you say that A is equal to 300 now. Now what will happen in this case? I mean, intuitively you would think that this value 100 will get changed to 300 here, right? And then again, so this label A will continue pointing to this memory location, and just this value A, value 300 will get updated in place of 100. But that's actually not what happens. So this is actually incorrect. Since integers are immutable types, you can't actually change this value at the same location in the memory. So for immutable types, you can see that whenever we you have to understand that whenever we assign a new value, for let's say here the immutable type is an integer, whenever we assign a new value, it is not updated at the same place. What happens is instead we create we allocate an entirely new memory for this particular block, for this particular value, and we put 300 in it, right? Let's say this is a memory location A and this is a memory location B. Now in this statement, so 300, so this is our new allocated memory which has 300. Now what will happen is that now this A label will start pointing to this location instead. Understood? So initially it was pointing to this memory address which had 100 value. Now it is pointing to a different memory address altogether, which is now a 300 value. Then again, if you have some other statement which updates it again back to let's say it's updated to 120, let's say, then again a new memory address will get created with value 120. Okay, and now this is pointing to this particular memory location. So this is what is called as an immutable type, like the value which can't be changed in the same location at memory. Now vice versa, we can take an example of a mutable data type. So let's consider, so there is another program that has this statement that B is equal to some list, right? So this is an empty list I have assigned. So what happens in memory when it is executing this statement, it will allocate some memory for this particular variable, and it will assign this empty list in that particular memory address, right? Let's create a label here also. Now B is pointing to this particular memory location. Now let's say if I now append some value to this list, let's say I append 400 to this list. Now what's the value of B here now? So B will look something like this, right? So what happens for mutable data types, this memory, whenever you try to update a mutable data type, it doesn't create a new memory address for that updated value. Instead it just updates it in the same memory location. So in the memory it would look something like this, that we have a 400 value inside this in the same object itself. So you can see these are all objects basically. So in Python everything is actually an object. So these are objects that are holding some value, and in case of immutable types, this value is different memory address is allocated with memory, and then the label gets updated to the new location. So this is what is mutable. So we can actually see that happening in action. I'll just show you by an example. So I have a main.py here, and let's say I declare this variable a to 100, right? Now, before this, let's look at a particular function which can help us understand this better. So we have a function called a id of a variable. So whenever you define or declare a variable, this is a property that is automatically attached to each and every object in your memory, and it is always unique in nature. So all the objects in your memory will have this particular id attribute, and each of them will be unique. So using this id attribute, we can demonstrate that how this mutable and immutable types are actually working. So if I try to print the id of this variable a, so you can see this more clearly. So if I do python main.py, so we get back this integer value, which is basically, this represents a memory location in your process, right? So this is just a memory address that is holding this value 100, and the label for this address is your variable a. Now let's do one thing, we just update it to 100, and let's see what's the id of this variable now. So now you can see this id is completely different from the id that we got earlier, right? So effectively what is happening is your program is allocating an entirely new memory location for this particular value. So it is not updating the value in place actually. So it is always creating a new, so it is creating a new memory location altogether. But let's take so this is an I can show you once more. Let's see this again. So you can see that we got this. Okay, so I think I didn't save the file earlier. So we are printing it 3 times now, and you can see that these 3 are entirely different numbers that we are getting. So these are all about immutable types, right? So now let's check out an example for a mutable type. So let's say we have B. So this is a list that we have, or let's say take an example of a dictionary here, right? We will just print the id of this dictionary, and then we will just assign a name that, let's say we assign it Niladri, right? So this is just a key value pair we have assigned, and now we will see what's the id of this variable. Oops. I don't think this was saved. Yeah, so here you can see that B, the memory address of B is not actually changing. So it is pointing to the same location that it was before, right? So we updated the dictionary here, but we are always getting the same memory address. So this is actually a mutable data type. I hope you got my point here, and I hope you are following till now. So that's mostly about what are mutable and immutable types. There are so you can search for what are all types are there. I have just added some examples here which are immutable in Python, right? And for mutable types we have lists, dictionaries, sets, or any user defined classes. So we will discuss classes in a later video. So any object of a user defined class is by default mutable in nature. We have to actually keep in mind some points when dealing with mutable and immutable types. So these are helpful when you are coding something. So a tuple itself cannot be changed because, as you know, it is an immutable type, right? But if it contains a mutable item, so let's say if your tuple is looking something like this, we have a immutable variable, immutable value, and then let's say a mutable value like a list here, right? So now this item can be changed. So this particular location can be changed. So this can be updated to, let's say, 1 comma 2 comma, let's say now we have this, right? So this is for the case of tuple. Also, one more thing, that we should never use a mutable type as the default argument in any function. Why? Because it is created only once when the function is defined and not every time you call it, right? So let's understand this point. So let's understand this with an example here. So let's say I have a function add item, so which takes an item as an argument and a my list that is a default argument here, and it has its value as an empty list. So we will see what will happen if, like, first I am adding this item 1 here and then 2, right? So if I run this program, let's see. Yeah, so if I run this program, you see that first, since I am passing 1 here, it is actually appending. So it is taking the default argument since we are not passing anything here, and it is appending 1 to it, right? But the next time I am trying to add 2, so you would expect that this should return an array with only one element that has 2 in it, right? But because lists are mutable in nature, so it will always, so when you are trying to update it, it will always point to the same memory location. Since I have defined this function here and I am assigning the empty list value in the default argument itself, it will always take this particular memory location for reference and always try to update in that particular location instead of creating a new one every time. So that's all for mutable and immutable types. See you in the next video.